Okay, so let's go ahead and work some more on these inverse trig functions. All right, so I'm going to look at question number 10, but I don't want to do that one next. Let's go ahead to this page and look at the example at the top of the back page first. All right, so here's one where you have a square root, so you know it's either arcsine or arcsecant, and there's that little x that's out in front. All right. Problem is the x is on the bottom, right? So it's not just a normal chain rule type problem. You might have been thinking you could do it using the chain rule, but don't write this. That 4x squared minus 9, when you do the derivative of it, you would get 16x, but that 16x or that x would need to be up here, not down on the bottom. So it's not just a typical substitution type problem. It's one where you're guessing it's going to be an inverse trig function. And because of that x that's out in front of the radical, that's why I'm going to arcsecant rather than going to the arcsine. All right, so let's get that on this sheet for you so you can see it right here. So it's got that little u out in front. And see, this is a little more general than just reversing what we used to get back in chapter 3 when we did these. All right, so the formula says that if something looks like that, it's going to turn out to be 1 over a arcsecant u over a again, but on this one it's got the absolute value around the u, and then plus c. All right, so we got to do like we did on the others. We got to figure out what's a, we got to figure out what's u, that type of thing. Notice the order is going to matter. Remember how u is going to be the piece that has the variable in it, and a is supposed to be a constant? And that matters because this is subtraction, so order matters. So it's good that it's set up the way it is. All right, so the a comes from the 9. A squared would have to be 9, so we're going to use 3 for a. U squared would have to equal 4x squared, so u would wind up being the square root of that, which would be 2x. Okay, now we're going to wind up doing the derivative and get du equals 2 dx, and we're going to move the 2 out of the way to be ready to do the substitution in a minute. Okay. All right, so this pretty much looks like I want it to look on this. So I'm going to wind up trying to get all the pieces plugged in. Okay, so I'm doing the one that has the 4x squared minus 9 on it. Okay. All right, so I'm about ready to do all the plugging in. Now there's a couple little things that can be weird when you're doing the secant one. So let's go ahead and see if this makes sense. All right, so I'm going to come in here and try to get all the u's into it. So this is 1 over x. Oh, wait, I don't want an x, right? I want a u. So hold your thought. We're going to have to figure out what x is, aren't we? Okay. And then I'm going to have square root of, and the 4x squared, I know that came from the 2x being squared. So that's my u being squared. And then the 9 came from the 3 getting squared. Okay. The dx I can see is 1/2 du, so I can get that in there. So I'm good so far with making the substitution, except for I got the issue of needing that x to be replaced with something with a u in it. All right, so this happens occasionally. And see right here, I have a formula that tells me that u equals 2x. So if 2x equals u, wouldn't x just wind up being 1/2 u? I'll write it that way. So right there, I'm going to put 1/2 u. I'm trying to get all the x's out of there and get u's in place of everything. Okay, so that looks good. And actually it works out pretty well because see that 1/2 that was out here, it's really basically on top or being multiplied, which is like being on top. And this 1/2 is on the bottom or being divided. So those would actually cancel out. And then this problem becomes just 1 over u square root of u squared minus 3 squared du, and I'm ready to apply the formula directly. Okay? So the formula says the answer that when you integrate this, that your answer is going to be 1 over your a, so that's 1/3. Then you're going to have arc secant. Then you're going to do the absolute value of your u, which in this case was 2x, and divided by a, which is 3, and then don't forget your plus c. And I do need to keep those absolute value on the 2x because with it being 2x, it could sometimes be positive, sometimes be negative, so I have to watch out about that. Right? And then that's going to be my answer to that problem. All right, let's back up and do the other one that turns out to be an arc-secant problem that's on the first page. All right. So let's look at this guy right here. Excuse me. All right, when I go to do this one, I'm still thinking about that arc-secant that I just did. It kind of has that feel. I see the square root. I see the x out in front. Okay, so I'm going to be focused on this formula right here. Okay, so I need to do like I did on the other one and identify the u and the a and make any adjustments that I need to make. Okay, all right, so watch. Okay, so on the arc-secant formula, your variable piece is supposed to be first, and it is here. Okay, so that's good. It's supposed to have potentially something out in front of the radical, and then you got your numerical part. So I kind of like the way this is written and the way it looks. All right, so my a squared is 4, which makes the a just 2. My u squared is x to the 4th, and so that means u is going to be the square root of that. Okay, we just did that, right, over here, didn't we? That same type of thing. So the u is going to be the square root of that. It's going to be x squared, right? So my du is going to equal 2x dx, okay? And I don't see an x that's on top or there in front of the dx, so I'm a little bit worried about that and wondering about how to handle it. And so there's a couple ways you might think about that. What I thought I would do is just go ahead and divide both sides by 2x, or multiply by 1 over 2x, okay, like this. Okay. And then actually, let me, I do kind of do it that way, but I think it might be easier for you if I do it a different way. Let me show you a different way. Let me just get the 2 out of the way like we normally do, and then I'll adjust for that extra x in a different way. That might make more sense to you. All right, so I want to try to plug everything in, get rid of the x's and get the u's into the mix. And I can pretty much do that in most of the spots, right? Like right here, underneath this, I know I have u squared minus 2 squared. The problem is right here where the dx is, I don't have an x with it. So I can't put 1/2 du in for that. I need that x there. And this x that's on the bottom already, that was on the bottom right there, okay, that x that was on the bottom is on the bottom. It's divided by, so it's not in front of that x right there. All right, so what I'm going to wind up doing is I'm going to just adjust things slightly. See if this makes sense, if you can make sense of this. All right, let me use red for this. So I want to get an x right here, okay, which means I want an x basically on top of that original problem. So if I put an x right there, I would need to divide by x or put an x in the denominator, which means I could put another x down here where that x squared is. basically, it's like I'm multiplying up here by x and I'm multiplying here by x. So I have an x on top and an x squared there that would have simplified to be 1 over x. So I'm just putting that back in so that I have an x dx. All right, now I'm ready to do my u's to get my u substitution in there. And actually, by doing what we just did, it helps a lot, because in place of that, I'm going to be able to put in the 1/2 du, okay? And then in place of this, I'll be putting a u. And then I already had the u squared minus 2 squared. I already had done that. I really should do all of that at the same time and have not done that until this step, but that's okay. All right, so then I'm to here. All right, so the 1/2 I can move in front. And then I've got this right here so that I've transformed it so it looks exactly like the formula for arcsecant. So I'm going to bring the 1/2 down, and then I'm going to multiply by 1 over a, which happens to be 2. And then I'll have arcsecant, and I have to do the absolute value of u, which is x squared, okay, over my a, which is 2, and then I'll have a plus c. All right, so a couple things we can do to clean it up is 1/2 times 1/2 would be 1/4. Okay, then arcsecant, that doesn't look right, and then arcsecant here. And then I really don't need the absolute value symbols because x squared is always positive anyway. So I would have just left those off, and then I would have had that plus c there at the end. Okay, so that's my final answer right there. Okay. All right, so that's 2 examples of the arcsecant situation. All right, now let's look at the one on the last page, and this is the last one we'll do. Let me see if we can get that up. All right, so here I'm looking at one, and it has this e in it, which looks a little strange, concerns me a little bit. But remember, we're going to make a substitution, trying to get this to look like one of the formulas that I can use that results in an inverse trig function. Okay, so let's go ahead and think about this. On this one, it doesn't have a radical, so I'm thinking it's an arctan problem, an arctangent situation. And so when I look at my arctan formula, let me go ahead and flip back to that. Okay, so when I look at that formula right there, I need a number squared plus some variable thing being squared. Okay, and then it should be just a 1 on top. Okay, and that's not what I see. So let's go ahead and see if we can adjust things a little bit. All right, so what I'm going to do is I am going to have this be the 1 over, and that e to the 2x that's on top is going to probably wind up being over here with my dx when I'm finished, if I correctly identify everything. So my a squared comes from the 4, or is 4, so a would be 2. And then what I'm going to wind up doing is figuring out what u is by knowing that u squared equals e to the 4x. So I know u would have to be the square root of that. It would have to be something times itself that equaled 4x. So u would have to be e to the 2x, since e to the 2x times another e to the 2x, you would add the exponents and get 4x. You see that? So u would be e to the 2x. All right, now I'm going to do the derivative. So du would equal e to the 2x, but that has an inside function, so I'd have to multiply by 2 and I'm writing this in differential form. So I have that dx there to the right. Okay. So I see the e to the 2x and the dx. I don't want that 2 that's there, so I'm going to multiply by a half to get that moved out of the way. Okay. All right, so then I have it almost looking like the tangent function exactly. So 4 is 2 squared. E to the 4x is e to the 2x squared. And then I have this e to the 2x dx. Dx down low there, dx. Okay. All right, so let's make the substitution with the u's. So this would be 2 squared plus u squared. Then this right here is going to be, all of this right here is going to be 1/2 du. Okay. I haven't integrated yet. I'm just getting the u in there to help me get my constant and everything where it needs to be. Okay. All right, so now let's integrate. So the 1/2 just comes down. Now I'm using the formula. So the formula for the arctan is what you're looking back at. So you're going to have the a is 2, so you're going to have 1/2. Then you're going to have arctan. You're going to have the u, which is e to the 2x. And you're going to have to divide that by the a value, which is 2. And then don't forget about the plus c. And then there's only a little cleaning up, which is 1/4. And I'll have 1/4 arctan e to the 2x over 2. We put parentheses so you see that, plus c. And that's not multiplied, that's the input to the arctan function. And that would be your answer. And that's the extent of what we're doing with section 5.8. Okay. So the big thing is this, you sometimes have stuff like 4 minus x squared under a radical, and you could integrate it, but it's like you need an x. Like if this had been a 2x right here, then that's old. That's not old, I'll say 5/5. Then that's 5/5. Okay. Then you could just let u equals 4 minus x squared. Du would equal negative 2x dx. There's 2x dx. Here's the 2x dx. You could make all those kind of substitutions like you would do in 5/5. Okay, compare that to what we're doing in 5/8. What happens there is if it had been just, say, a 2 or just a 1, and you're trying to integrate, okay, well, I don't know what to do about that, the fact that there's no x there. That's what makes me think maybe I need to go look for a function. And this would be an arcsine problem. Okay.